Hello friends, welcome to this third video on complex integration under the category Cauchy residue theorem. We'll have a quick recap on the Cauchy residue theorem, which states that integral over the closed curve C f of z dz is 2 pi I times summation of the residues of the function at the poles z1, z2 up to zn. So 2 pi I into addition of estimate the residue at the poles, add them up and then multiply by 2 pi I. This is what your Cauchy residue theorem states. Now to estimation of residue, there are going to be two categories. We can estimate the residue at a simple pole, which is given by limit z tending to a, z minus a into f of z. And at multiple pole, which is going to be of order n, the value can be estimated as limit z tending to a 1 by n minus 1 factorial, the derivative d power n minus 1 by d z power n minus 1 multiplied by the factor z minus a the whole power n into the function f of z. Keeping all these primary things in mind, we will do a problem which covers evaluation of the integral using your Cauchy residue theorem. As we have already said, if the methodology hasn't been mentioned, you are free to choose your method. Like you can do it either by the Cauchy integral formula method or by using Cauchy residue. But if the requirement of application of a particular methodology is given, kindly stick on to it. Otherwise, we will be losing our marks on it. Okay, so we will find the evaluation of the integral z minus 1 by z square plus 2z plus 5 dz under three different boundaries: mod z equal to 1, mod z plus 1 plus I equal to 2 and mod z plus 1 minus I equal to 2. To get started off with, the primary requirement is going to be my poles. How to estimate the poles? The poles are given by equating your denominator to 0. So I have z square plus 2z plus 5 to be equal to 0. Z value is going to be a quadratic equation. We need to factorize it. Z is given by minus b plus or minus b square minus 4ac the whole root divided by 2a. So now this makes it as b in place of this is my a, this is my b, this is my c. So I have minus 2 plus or minus 2 square minus 4, 1, 5 the whole square root divided by 2 times of 1. So it minus 2 plus or minus 2 square makes it as 4 minus 5 fours are going to be 20 the whole root divided by 2. So now this makes it as minus 2 plus or minus square root of minus 16 divided by 2. What do we know about square root of a negative number? It is going to be I. So I have it as I with square root of 16 standing for 4. And now divided by 2. 2 can be cancelled off on each sides. I have the poles to be equal to minus 1 plus or minus 2i. Hence, I have my poles to be equal to z is equal to minus 1 plus 2i, which is going to be a simple pole. And the next one is z is equal to minus 1 minus 2i, which is again a simple pole. So both my poles are going to be simple in nature, and hence my denominator z square plus 2z plus 5 can be rewritten in terms of this poles as z minus your first factor. So it is minus of minus plus 1 minus 2i into z minus of the second factor. Minus of minus makes it as plus 2i. So keep in mind your denominator, which is z square plus 2z plus 5, can be written as the product of the whole as z plus 1 minus 2i and z plus 1 plus 2i. We need to replace in this way so that it will be easy for the cancellation when we apply multiplication of the factor into the function f of z. So now we will move on to the second step, which is identifying our boundary. What is our boundary for the first case? Mod z is equal to 1. What does mod z is equal to 1 represent? Mod z is equal to 1 is going to represent x plus iy to be equal to 1. So I have x square plus y square to be equal to 1. Squaring on both sides, I have x square plus y square to be equal to 1 square. This represents a circle with center 0, 0 and radius to be equal to 1 unit. After identifying our step 2, what is the step 2 now? I have identified the boundary. Plot your boundary. So the next case is going to be keeping my center as 0, 0 and radius to be equal to 1 unit, I have drawn my boundary. Now what are going to be my poles? My poles are z is equal to, it is going to be -1 plus 2i, and z is equal to -1 minus 2i. When I convert it in terms of the Cartesian coordinate x comma y, this pole -1 plus 2i turns out as, because this is of the format x plus I y, in place of x I have -1 and in place of y I have 2. So this pole corresponds to the point -1 comma 2, and the second pole corresponds to the point -1 comma -2. Now the step 3 is going to be, my step 2 was plotting the diagram. My step 3 is identifying the position of the poles in the given boundary region. What is going to be my -1 comma 2? -1 over here, 2 in the positive quadrant. So this is my position for the first pole. What is the position for my second pole? My second pole is going to be -1 comma -2, -1 and -2. So this is my second pole. What do you think is going to be the position of my pole number 1 and pole number 2? Yes, you are right. With respect to the boundary, both the poles 1 and 2 lie outside. So the poles lie outside the boundary mod z is equal to 1. So when it lies outside, what happens to the integral of the function f of z dz? This automatically turns out as 0. So the value of the integral, whatever be the pole, if it lies outside the boundary, the value of the integral turns out as 0. So we are done now with the first part. Now let us move on to the second part. What is going to be my second boundary? Mod z plus 1 plus I equal to 2. Come on, let us trace this boundary now. Modulus of z plus 1 plus I equal to 2. I have this as x plus iy because this is my z, and extra I have plus 1 plus I to be equal to 2. So club your real part. So this makes us as x plus 1 the real part, and club your imaginary part y and plus I times I is taken common, y plus 1 will be left out. So this is my modulus to be equal to 2. How to remove the modulus? Square the real term and square the imaginary term. Then take your square root. This is going to be the magnitude of the complex number. To remove the square root, square on both sides, which gives x plus 1 the whole square plus y plus 1 the whole square equal to 2 square. Yes, this equation can be identified with that of the equation of the circle. Circle with center to be equal to, what is going to be the center? -1. And what is this center? -1. So okay, so the center's coordinate is going to be -1 comma -1. And what can be said about the radius? Radius is going to be equal to 2 units. Now plot the point -1 comma -1. So this is my point -1 comma -1. Now radius is 2 units. So 1, 2, 2 points to my left. 1, 2, 2 points to my right. 1, 2, 2 points to my bottom, and 1, 2, 2 points to my top. After plotting your boundary points, which is 2 units in each of the direction, connect all of this boundary by means of a circle. So now our boundary, which is modulus of z plus 1 plus I equal to 2, is got. What is the next thing? I need to identify my position of the poles. What are going to be my poles for me? My poles is z is equal to -1 plus 2i and z is equal to -1 minus 2i. The first point makes it as -1 comma 2, and the second point makes it as -1 comma -2. Now let us check the position of these poles. Where is the point -1 comma 2? -1 over here and 2 over here. So this pole is going to lie outside for me. Now let me check the position of the second pole. Where is going to be my second pole? my second pole, which is minus 1 comma minus 2. This is my minus 1, this is my minus 2. So this is my point minus 1 comma minus 2. So where is my second pole? Second pole lies inside. So of this, one of the poles is going to lie outside and one of the pole is going to lie inside. So our pole will be our residue will be estimated only for the quantity that is going to lie inside. So which is the point that lies inside? Minus 1 and it is going to be minus 2. So I will be estimating just the residue at the position minus 1 comma minus 2. So now we are ready to estimate the value of the residue. So I will be estimating the residue at the pole z is equal to, which lies inside, minus 1 minus 2i. Minus 1 minus 2i. What type of pole is this? This is going to be a simple pole. Now we will have to first copy paste our function f of z, which is given by z minus 1 divided by what we have done to the denominator. The denominator has now been transformed into product of the factors in terms of the pole. So I will copy paste this as z minus 1 plus 2i into z minus 1 minus 2i. This is my value of my function. Now I need to find the residue. So the next thing which we need to do is recollect the formula for residue at a simple pole. The formula can be recollected as limit z tending to a, z minus a into f of z. So we need now this as limit z tending to what is going to be my pole, minus 1 minus 2i z minus a. So minus of minus will become plus 1 plus 2i into my function f of z. So this is z plus 1 plus 2i. Copy paste your function f of z from over here. Z minus 1 divided by z plus 1. Sorry, this is going to be copy pasting over here. This is going to be plus 1 plus 2i into, this is going to be z minus 1 my plus 1. This again is going to be plus 2i. Over here this is going to be plus 1 minus 2i. So now our function has been rewritten. Now applying the limit z tending to minus 1 minus 2i, what happens? This factor which is common gets cancelled off. For the remaining of the left out quantities, we can substitute z to be equal to minus 1 minus 2i. So replacing the numerator z with minus 1 minus 2i, and now you have an extra minus 1. Denominator z takes the value minus 1 minus 2i, and the left out quantity is plus 1 minus 2i. Now we will try to simplify this. Minus 1 makes it as minus 2 minus 2i divided by minus 1 and plus 1 cancels off, so that makes it as minus 4i. I can take a minus 2 common outside. I will be left out with 1 plus I divided by minus 4i. Minus can be cancelled off, 2 can be cancelled off, leaving you with the final answer as 1 plus I divided by 2 times of I. So this I can mark it as my residue number 1. And what happens to my residue number 2? My residue number 2 was lying outside. So what will happen to the value of the residue that lies outside? The value will become equal to 0. So now what happens in the next stage is we can go for the evaluation of the integral of the function f of z dz, which is going to be given by 2 pi I times summation of my residues. So it is 2 pi I times residue 1 plus residue 2. So it is 2 pi I times, what was the residue 1 that lies outside, so value is 0, and about the function of residue 2, we had this to be equal to 1 plus I divided by 2I. So it is 1 plus I divided by 2I. So now this I can be cancelled off, 2 can be cancelled off, leaving us with 1 plus I times pi. So the evaluation of the integral z minus 1 divided by z square plus 2z plus 5 dz in the boundary modulus of z plus 1 plus I to be equal to 2 is given as 1 plus I times of pi. So this completes our second subdivision. Now moving on to the third subdivision. What is going to be the third boundary for me? The third boundary is given by 1 plus I minus I equal to 2. So let us find what does this represent. So we move on to find out what is going to be z is equal to 1, z will be equal to z plus 1 minus I equal to 2. So now x plus I, y is my z, plus 1 minus I is going to be my modulus. Combining the real part, I have it as x plus 1, and combining the imaginary part, I have it as y minus 1. This modulus is going to be equal to 2. So remove the modulus by squaring the real part and the imaginary part separately. So with the square root over here, this can be removed by squaring on both sides. Hence I have this to be equal to x plus 1 the whole square plus y minus 1 the whole square equal to 2 square. This represents a circle with center as, the center for this x coordinate will be minus 1 and for the y coordinate will be plus 1. So center is minus 1 comma plus 1 and radius to be equal to 2 units. So now mark the point which is going to be minus 1 comma plus 1. Mark 2 points or 2 units to your left, 2 units to your right, 2 units to the top and 2 units to the bottom on all sides. Then fix your boundaries. You can draw your circle and your circle mod z plus 1 minus I equal to 2 is now ready. What is going to be the next task? The next task is find the position of the poles. What are going to be my poles? Z is equal to minus 1 plus 2I. Z is equal to minus 1 minus 2I. So I have it as minus 1 comma 2 and minus 1 comma minus 2. So let me go for the point minus 1 comma 2. Where is my point minus 1 comma 2? This lies inside. So this pole is going to be having a residue inside my boundary called as C. Now coming to the second pole. What is going to be my second pole? Minus 1 comma minus 2. Minus 1 minus 2. Where does this pole lie? This pole lies outside my boundary of the circle. So what will happen to the residue at this particular point called as minus 1 comma minus 2? At this point minus 1 comma minus 2 residue does not exist or it becomes equal to 0. So I will have to estimate the residue only for the point that lies inside. So I will be estimating the residue for the simple pole minus 1 plus 2I. So my next task is to estimate the residue of the function f of z at the point, what is going to be my point? Minus 1 plus 2I. Z is equal to minus 1 plus 2I. So this is where I am going to estimate the residue. Okay, so what is going to be my function f of z? My function f of z is z minus 1 divided by z plus 1 minus 2I z plus 1 plus 2I. Now to recollect the formula for a residue which is going to be of a simple pole. So we have the formula as limit z tending to a, z minus a into f of z. So we have this as limit z tending to the pole which is minus 1 plus 2I. So I have the factor as z, minus of minus makes it as plus, minus 2I into our function f of z. Now copy paste our function z plus 1 minus 2I. This is going to be my function z minus 1 divided by z plus 1 minus 2I and z plus 1 plus 2i. Now when I allow my limit z tends to the pole minus 1 plus 2i, this quantity gets cancelled off with this quantity, leaving us with just the remainder of it. Now fix your z at minus 1 plus 2i in all the positions where we have. This gives us minus 1 plus 2i. There is a minus 1 over here, and denominator is minus 1 plus 2i. I have plus 1 plus 2i. So this makes it as minus 1, so minus 2, and you have a plus 2i divided by minus 1 plus 1 cancels off. 2i plus 2i makes it as 4i. When I take a minus 2 common outside, you will have 1 minus I divided by your 4i. This goes off 2 times. So what is going to be the residue? It is going to be minus of 1 minus I divided by 2i. Now the residue has been found. The last stage is evaluation of the integral f of z dz, which is given by 2 pi I times summation of the residues, which is 2 pi I times residue 1 plus residue 2, which is 2 pi I times, what is the residue 1? It was lying outside, so it vanished. And what is our residue 2? Residue 2 was equal to minus of 1 minus I. So this was minus of 1 minus I divided by 2i. 2i and 2i can be cancelled off. So I have minus pi into 1 minus I to be the value of the integral over C f of z dz in my boundary. What was the boundary? Boundary was z plus 1 minus I equal to 2. So this completes the third part of our integral. So do it stage by stage. For each of the stages, the boundary is going to be different, and hence the positioning of the poles is also different. Just estimate the value of the pole that lies inside, and for the poles that lie outside, residue will automatically become 0. So add up the residue, multiply by 2 pi I to get the final value for your value of integral. Thank you.